Alright, Year 11. We're up to the last syllabus point of the chapter. We have to construct relevant half equations and balance overall equations to represent a range of redox equations. We're putting all of our knowledge together to deal with every redox reaction that we can and give a balanced overall equation. Okay, words. We've seen that polyatomic ions can take part in redox reactions and also neutral molecules, okay? So we need to start balancing those. Okay. All right. Let's look at balancing a half equation involving a polyatomic ion. The dichromate ion, I've got the charge wrong on there, haven't I? That should be a 2 minus in there. Is reduced to form the chromium ion. Okay. So first up, okay. So we're talking about a half equation and balancing a half equation. What we know and what we're given from the equation is we're starting off with dichromate and it's going to chromium 3+. Okay. We're aiming to balance this half equation because you can see from this half equation you haven't got a balance because you've only got 1 chromium on the right and 2 on the left, and you've got these oxygens as well, okay? There's some rules that we need to go by, okay? Balancing half equations. Number 1, we need to balance any non-hydrogen or oxygen atoms, as in normal chemical equations. And this is why I chose dichromate. It's often where people make mistakes. If we've got 2 chromiums on the left, we need 2 chromiums on the right, okay? So we put a 2 in front of the chromium 3+, okay? Out of all the redox equations, or let me put it a different way. These come up sometimes in the HSC in exams, and dichromate comes up because people forget this first step, okay? They're testing that first step. That's a good way. Dichromate going down to 1 chromium. So you need to balance that chromium first because the only other atom is oxygen, and we'll deal with that later. Okay, so now we've got 2 chromiums on the right. Second thing is we need to balance any oxygen atoms, and we balance it by adding water molecules to the opposite side. Okay, new and unusual. Okay, so here's our initial. We've got 7 oxygens on the left. We need to balance it by, we're getting 1 oxygen per water. We need to balance it by adding 7 waters to the right. Okay, so what we've added there in red, 7 waters to the right. Step 3. What we need to do is balance any hydrogen... Start again. Balance any hydrogen atoms, and we balance them by adding H+, or acidic protons, ions to the opposite side. Okay, so here we can see we added those 7 waters. So now we have 14 hydrogens to balance out. So we're going to have to add 14 H pluses to the opposite side. Okay, at this stage you should have conservation of mass. 2 chromiums, 7 oxygens, 7 oxygens, 14 hydrogens, 14 hydrogens. Okay, final step is we need to balance the charges, and we balance the charges by adding electrons to the opposite side. Okay, so count up the charge on the left hand side here. We have 2 minus and 14 pluses. Okay, so that equals 12 plus all up. On the right hand side, we've got 2 3 pluses, so that's 6 plus, and water's neutral, so we've got 6 plus. So we need these 2 numbers to equal, and we need them to make them equal by adding in electrons. So we're going to add in negative charges so that they equal the lowest charge. The lowest charge is 6, so we need to take 12 down to 6. So we're going to need 6 electrons to balance it out. Okay? That final step will give us a balanced half reaction for every possible scenario. Okay? What we do then is once we have 2 balanced half equations, one hopefully oxidation, the other reduction. If you don't, you haven't got a redox reaction and you've got a problem. What we need to do is, we did it earlier in the chapter, we need to make sure that the same number of electrons are being given up as the same number are taken in. Okay? And we need to multiply the stoichiometry by those of the half reactions to get them to equal. So here in my example, I've got aluminium being oxidized and it gives up 3 electrons. And here I've got H plus going to H2. And so this one's producing 3, this one's consuming 2. I need to multiply to get 6. Okay, so the first one with 3, I need to multiply by 2 to get the aluminium to give up 6 electrons. And the hydrogen needs to be multiplied by 3, so it consumes 6 electrons. So here, 2 aluminiums plus 2 aluminiums go to 2 aluminium ions plus 6 electrons, and 6H plus and 6 electrons go to 3 hydrogens. Now we got 6 electrons being transferred. Now we can add them together. So once we have them all added all together, write them somewhere like something like this, and just write down the left hand side and write down the total right hand side. From there, what we do is cancel. Okay, anything appears on the left and the right, the same we cancel, and hopefully if you've done it right, all your electrons should go. And here they did, the 6 electrons went. Sometimes with some more complicated things, you can get some H pluses on both sides or some waters on both sides cancelling out too, but they're on the more difficult ones. And then once you start cancelling out, you'll come to like a net ionic equation, and you just write it all down, an overall one. Let's do an example. We've got the dichromate ion. Undergoes a reaction with iodide in solution to produce chromium 3 plus ions and iodine. Okay, be careful of the iodide and iodine. Give simplified half equations for each element. Okay, we have, let's do it with the chromium first. I've got the dichromate going to chromium 3 plus. Okay, let's start balancing it. We just did it before. 2 chromiums, we need to balance, going back a step, we need to balance anything that's not oxygen or hydrogens. 2 chromiums on the left, we need 2 on the right. Balance any oxygens with water, 7 oxygens on the left, 7 waters on the right. Okay, now balance any hydrogens with H pluses. We've got 14 hydrogens on the left, so we need to add 14 H pluses. Sorry, on the left. We had 14 H pluses, 14 hydrogens on the right. Okay, now I've got conservation of matter, but I might not have conservation of charge. My charge is, I'm going to change colour. My charge on the right is 6 plus from my 2 chromium 3 pluses, and here it's 14 plus minus 2, 12 plus. So I need to add 6 electrons to get that down to 6 plus. Okay, so there's my balanced half equation. All right, for chromium, I'm going to do my other one. What did we have? We had iodine in solution. It's a halogen, so it's I2. And it's going to iodide. Oh, hang on, haven't got it around the wrong way. Dichromate undergoes a reaction with iodide. Oh, lucky I checked that. Terrible. Iodide is the reactant, I minus, and it's producing iodine, I2. Okay. First step, balance any non-oxygen or hydrogens. Well, I have 2 iodines on the right. I need 2 on the left. Okay. Now balance any oxygens with water. I don't have any oxygens. Any hydrogens with H pluses. I don't have any hydrogens. Now balance the charge. Okay. I'm going to write the charge on top. 2 minuses is 2 minus, and this side is 0. So they need to go to the lowest one, so I need 2 electrons on the right-hand side. Okay, and this is good that they're on the right because the dichromate, they're on the left. So the dichromate was consuming electrons, and the iodide was producing electrons. So that's good. We've got a redox reaction happening. Okay. By determining oxidation numbers, determine which half equation is being oxidized and which is reduced. I'm going to scribble this on top, okay? I might change my color to green. Is it distinctive against the blue? Maybe a dark green. Okay. So the chromium in dichromate, actually, let's do it under here. Let's determine the charge, so the oxidation number of chromium in dichromate. So the charge on the ion is going to equal 2 times the oxidation number of chromium plus 7 times oxygen. So 2 chromiums plus 7 times negative 2. 2 chromiums minus 14. So 2 chromiums is going to equal 12. Chromium is starting off at positive 6. So I'm going to write it here, positive 6. And it's going down to 3 plus. So it's being reduced. So being reduced. I'm paranoid that I've got it around the right way. Why am I thinking wrong here? It's going from positive 6 down to positive 3. So it's reduction. And let's just check this one. Okay, the iodine, it's a monatomic ion. Its oxidation number is -1 and it's going to 0. So it's going up. So it is being oxidized. So I minus is being oxidized. Don't worry about my brain fart there. I just had a paranoid moment that iodide was also being reduced, but it's not. It's being oxidized. It's going from oxidation number of -1 to 0. All good. Okay. State which chemical species is the oxidant and which is the reductant. Well, if dichromate is being reduced, it must be the oxidant because it's causing the oxidation. Is oxidant. Okay. Iodide is being oxidized, so it's causing the reduction of dichromate. So I minus is the reductant. Okay. Oh, it hasn't asked us to... Oh, look. There's my previous working. Okay. Let's scribble on here. Let's do this one. Dichromate in solution reacts with sulfur dioxide gas. Bubble through the solution to produce chromium 3 ion and sulfate. Okay. Determine the oxidant and the reductant. So dichromate, Cr2072 minus. Let's copy. That's what I do in exam. Plus 14H plus 6 electrons. And it was 2 chromium 3 pluses and 7 waters. Why not? Okay, so there's my half equation for dichromate. And it's being, from the previous question, it's being reduced, isn't it? Because it's going from 6 plus to 3 plus. Okay. What do we got? We got sulfur dioxide gas. Sulfur dioxide producing SO4 2 minus. Okay, let's do our balance half equation here. Balance any non-oxygen or hydrogens. Okay, so sulfur, 1 on the left, 1 on the right, we're good. Balance any oxygens with waters. We have 4 oxygens on the right and 2 on the left, so we need 2 waters on the left. Okay, balance any hydrogens with H pluses. We have 4 hydrogens now on the left, so we need 4 H pluses on the right. Have we got conservation of mass? 4H, 4H, 4 oxygens, and 4 oxygens, and 1 sulfur and 1 sulfur. So we're all good. Now we need a balanced charge. Okay, charge on the left is, we got neutral only, so 0, and charge on the right is 2 minus plus 4, so it's positive 2. So we need, I might as well keep it in red. We need 2 electrons on that side. Okay, and that's promising because it's opposite to the one above. Okay, so chromium is going from 6 plus to 3 plus, so it's being reduced. Sulfur is going from, its oxidation number here is 0 equals sulfur and 2 oxygens, which is -4, so sulfur equals +4. Okay, what is it here? It's sulfate. -2 equals sulfur and 4 oxygens. Sulfur -8, so sulfur equals 6 plus. Okay, so it's going from 4 plus to 6 plus, so it's being oxidized. Okay, so if sulfur is being oxidized, sulfur is the reductant. Oh, sulfur dioxide is the reductant, I should say. So dichromate is oxidant. Okay, produced a balanced full redox equation. Oh, I've got a lot of scribbling, but we can see 6 electrons, 2 electrons, okay? 2 will go into 6, so we just need to multiply that one by 3 times, okay? So, put my big reaction arrow on there. I need the dichromate one as it is. I'm going to write everything on the left. And I'm also going to add everything on the left-hand side of the sulfur one multiplied by 3. 6 waters plus 3 sulfur dioxides. Okay, now the right-hand side of the chromium one, 2 chromium 3 plus 7 waters. And I need 3 lots of the one below. So 3, oh, go back, 3 sulfates, and 3 times 4 H pluses is 12 H pluses, and 3 times 2 electrons is 6 electrons. That's good. I was hoping for 6. Let's cross out anything that's on both sides. Hopefully the electrons. What else can I do? 12 H plus, 14 H plus, so that gets rid of the 14, so 2 extras left over. We have water on both sides, 6 and 7, so 6 will disappear and just the 1 is there. And I think that's it, so let's write what we got left. So our dichromate, oh, let me fix that up, 07, 2 minus, plus it was 2H plus 3 sulfur dioxides is going to 2 chromium 3 pluses plus 1 water plus 3 sulfates. That's as hard as it's going to get. Alright, I've got another problem though. Let's see if it's harder. And I'll have to eat my words. Alright, nearly there. Let's do this last one. Permanganate in solution reacts with chromium 3 plus ions to produce the manganese 2 plus ion and the dichromate ion. Alright, so MnO4 minus goes to Mn2 plus, and we've got the opposite of what we're talking about before. Okay, so let's write the opposite of what we've done before. So 14H plus and 6 electrons. Notice it's the reverse of what we did before. What was on the side? 2 chromiums and 7 water. 2 chromiums plus 7 water. Notice it's the reverse. Okay, now let's balance our permanganate ion on top. 1 manganese, 1 manganese. Now balance the oxygen. So we have 4 on the left, so we need 4 waters on the right. Balance those 8 hydrogens, 8H plus. So the charge on the left is 7 plus, and the charge on the right is 2 plus. So we need 5 electrons on the left, okay? 5 given up by 6. Oh, this is a mean one. Okay, that's actually part B. What's the oxidant and what's the reductant? Okay, I forgot that part. Let's swap to green. Manganese here, it's going to 2 plus. And it's the chromium starting at 3 plus. So the manganese in permanganate, -1 equals, this is the terrible colour, isn't it, because of the blue. -1 equals manganese plus 4 oxygens, manganese minus 8, so manganese equals plus 7. So we're going from plus 7 to plus 2, so that's a reduction. Let's just check this one. So you're starting at 3 plus, and the dichromate, we've done that earlier, it goes to 6 plus, doesn't it? Yeah, there we go. So we've got an oxidation. So we have got a redox reaction. So chromium is oxidizing, so it must be the reductant. And the permanganate is reducing, so it must be the oxidant. Okay, now we've got to slam the two half ones together, and we've got 5 and 6. That's a horrible combination because they're going to have to go to 30 electrons, isn't it? There's nothing easier. So we've got to multiply 1 by 6, 1 by 4. Oh, that's terrible. Lots of maths. That's okay. So, big arrow. We've got to multiply the top one by 6 and the bottom one by 5. So 6 eighths are 48, aren't they? Need my calculator now. 48H plus 6 MnO4 minus plus 30 electrons and 5, so that's 10 chromium 3 pluses and 35 waters. Okay. On to the right hand side, we need 6 Mn2 plus, and we need 6 fours of 24, so 24 waters, and we've got 5 dichromates, and 5 times 14 is 70, isn't it? 70H plus, and the 30 electrons. Horrible big numbers here. Okay, let's cross out anything. Hopefully, good, our electrons are 30 and 30. H pluses, we've got 70 versus 48. So 70 minus 48 is 22. Oh, so I need to cross out the 48 and cross that one out and put 22, H plus. And then we've got waters, 35 versus 24. So the 24 will go, and what's left over is 9. All right, let's rewrite it. 6 permanganates plus 10 chromium 3 pluses plus 9 waters are going to 6 manganese 2 pluses plus 5 dichromates plus 22 protons. I don't think it was any harder, there was just bigger numbers. Alright, I think we've done enough balancing there. You can have a go yourself on that worksheet. And look, there's the end of the chapter.